Welcome here. Today we are going to solve exercise 3.2 of class 6th NCERT book Playing with Numbers. Chapter's name is Playing with Numbers and exercise is 3.2. So what we have studied in the theory was the prime number and the composite numbers. Okay. So all the questions and exercises will be around this only and composite numbers. Okay, so one by one we will solve and you can see how it is being solved. Okay, so what is first question? First question is, what is the sum of any two sum of any two and a part is odd numbers. Okay, any odd number. So first part is, what is the sum of any odd number? Okay, so it is asking whether the sum will be an odd or even number. Okay, so you take any two odd numbers. Okay, any. Okay, for example, you are taking 3 as odd because 3 is odd number and 5 is also a odd number, so it will always be an even number. You take any one, take 1 plus 9, it will be 10. So this is even, both are the even numbers. So what we will write, sum of any two odd numbers will be an even number. Okay, so this will be the answer. Okay, so it will be even number. It will be an even number. Okay. And the b part is, what is b part? Sum of any two even numbers. Okay, so this will also be an even number. Okay, even number. So sum of any two even numbers will also be even. Take example of 2 plus 4 will be 6. 10 plus 20 equal to 30. Okay. So sum of any two even numbers will always be an even number. Okay. So what you have seen, that sum of two odd numbers are also even number and sum of two even numbers is also an even number. So you can think that when the sum of two numbers will be odd numbers. Okay, so you need to understand that if two numbers are added and any of the two number is an odd number, okay, then I means not any but either one. Okay, so for example, we have 5 as odd number and another is even number, so it will always be an odd number. Okay, if one number is an odd, then it will be odd. Okay, so this is that. Okay, so now come to second question. Question number 2 is, state whether following statements are true or false. Okay, so statements are there, so I will not write the statement but I will read out the statement and I will tell you whether it is true or false. Okay, and explain it also. So sum of three odd numbers is a is even. Okay, so this is false. Okay, sum of three odd numbers. Okay, you take any three odd numbers, it will always be an odd. Okay, take 1 plus 3 plus 5. Okay, these are the first three odd numbers. Okay, as we have already explained that sum of two odd numbers will be even number, and if an even number is added to an odd numbers, then it will be an odd number. We have already explained in the previous question. So if you add the three odd numbers, it cannot be even number. Okay, so it is false. Okay, now the second b part question. What is b part? B part is sum of two odd numbers and one even number is even. Okay, sum of two odd numbers, we have already seen that sum of two odd numbers even and one even numbers is even. Okay, so it will be even only. Okay, so what they are saying, that two odd numbers, take 5 and 7 for example, sum of two odd numbers. Okay, so what will be this? It will be 12. Sum of two odd numbers and one even. Okay, one even. Sum of two odd numbers is 12 and take one even also. 12 plus, suppose take even number as 4, so it will be an even number. So this is saying that sum of two odd numbers and an even number will be an even number only. So this is true because it will be even number only. And C is the product of three odd number is an odd number. Okay, so this is true. Okay, so take any number, odd number. Just for example, you will take 3 and 5. Okay, this will also be an odd number. Okay, if you take two odd numbers and multiply together, this will be odd number. But they are talking of three odd numbers, so three odd numbers will also be an odd number. Suppose we are taking 3 multiplied by 5 multiplied by 7. Okay. Okay. So this will be 105 and this is an odd number. So you can take it. You will find it that this is an means odd. So this is true. Okay. In this question it is true. And now come to D part of the question. So what is D? If an even number is divided by 2, the quotient is always odd. No, never. Okay. No, it not never. It can. It is possible. It is possible. So it is saying that the if an even number is divided by 2. Okay. So even number take 10. Okay. If it is divided by 2, then it will give 5. Okay. So what is this? This is an odd number. Okay. What the question is saying, this will always be an odd. Okay. In one case it is odd, but let's take another number 12 divided by 2. It is giving 6. This is an even number. Okay. So it means it will not be always odd. Okay. Sometimes it can be odd. So this is false. Okay. The statement is false. Now, part E. What is part E? So we are explaining each and every question, although we can write the direct answer, and you need to write direct answer only because they are asking for the true and false. So you need to write F for T only. But I am explaining you so that you can understand the complete concept. Okay. So the understanding the concept is very important. All prime numbers are odd. Okay. So the question is all prime numbers are odd. Okay. So this is false. Why it is false? Because 2 is also a prime number. Okay. 2 is a prime, but it is even. Okay. Prime number which is even. This is even. Okay. Sorry for my writing. Okay. So E is false. Now come to F. So F is prime numbers do not have any factors. Okay. So do not have any factors, they are saying. Okay. So this is false. Why it is false? Because prime numbers has two factors. Suppose 7 is a prime number, so it has two factors. One is 1 and another is 7. 11 is a prime number and it has factor as 1 again. Okay, so this is false. Now the sum of two prime numbers is always even. Okay, this is not true. Okay, because let's explain. Sum of G part, it is G. It is saying that sum of two prime numbers is always even. Okay, it is not always even, but most of the time it is even. Okay, for example, these are the two prime numbers. 11 plus 7, this will be 18. This is even. But you know that 2 is also a prime number. If you add 2, then what you will get? You will get 13, which is an odd number. Okay, here it is even. Okay, so this is not always true. Okay, so what is this? Answer will be false. False. Okay, so you should know the logic actually. That is important. Okay, now G, after G we have come to H. and h is 2 is the only even prime number. This is true. Okay, we have already we already know this. So 2 is the only even prime number. So now come to I, question number I, and this is saying that all even numbers are composite numbers. Okay, so what is this? All even numbers are composite numbers. This is false. Why it is false? Because for all numbers it is true, but for 2 it is not true. Okay, so we cannot say all even number, because 2 is an even number and it is a prime number. Okay, so being a prime number, it is not a composite number. Okay, so this is false. Now J, what is J? The product of two even numbers is always even. Okay, this is true. It's always even. Take any example. Take 12 multiplied by 6. You will get 72. Okay, so it will always be an even number. There is no doubt about it. Okay, so we have done the question number 2, all parts. Now we have come to question number 3. Okay, question number 3. Okay, so question number 3 is the numbers 13 and 31 are prime numbers. What they are saying? 13 and 31 are prime numbers. Certainly they are. Okay, they are. Both these numbers have same digits. Okay, same digits, 1 and 3. 1 and 3 in both of the numbers, that is there. Okay, 1 and 3. Find such pairs of prime number up to 30. Okay, up to 100. Okay, so we need to find such numbers, such prime numbers, pair of such prime numbers. Okay, whose digits are same. Okay, okay, up to 100. Up to 100 we need to find out. So you need to see that table. Okay, and you need to find out such numbers. Okay, so for example, you can take that 17 is there. Okay, 17 and 17 and 17 and 71. Okay, this is also prime, this is also prime, and both in both of them the digits are 1 and 7. Okay, another example you can take as 37 and 73. Okay, another example, if you want to take 79, sorry, take 79 and 97. Okay, so these means pair you can consider. You can find other numbers also. If you want to get, you can go and see to the table and find out. Okay, so this must be have written. Okay, now fourth question. What is fourth question? Write down separately the prime and composite numbers less than 20. Okay, so they are saying that less than 20, they are saying you need to write prime numbers and composite numbers. Okay, prime and composite. Okay, prime and composite. So we'll write all numbers over here. Fine. As you know, one is neither a composite nor a prime, because only one has only one factor, so we'll leave it. So prime will start with 2. Okay, 2 is there, then 3 is there, then 5 is there, 7, 11, 13, 17 and 19. Okay, up to 20 these are that. And here we come to 4, 6, 8, 9, 10, 12, 14, 15, 16. Okay, and 18. Okay, up to 20, means you can include 20 also. Okay, fine. So this is the means prime numbers and composite numbers up to 20. Fine. So this is question number 4. Acha, no, it's not up to 20, but it is less than 20. So 20 will not be, 20 will not come. Okay, this one. Okay, now we have come to question number 5. Okay, question number 5. So question number 5. So what is the greatest prime number between 1 and 10? Okay, so it is saying greatest prime number. Greatest means greatest prime number between 1 and 10. Okay, so we'll write down the all prime numbers between 1 and 10, and the highest number will be the answer. Okay, so it starts with 2 3 2 2 3 5. Okay, 7. Okay, so 7 is the highest prime number. Okay, means between 1 and 10. So your answer is 7. Okay, 7 is the greatest prime number. Okay, so this is the answer. Now we have come to question number 6. Question number 6. Okay, so question number 6 is express the following as sum of two odd primes. Okay, so as a sum of two odd primes, we need to express few numbers are there. We need to express these numbers as sum of two odd primes. So first number is 44. Okay, so we need to represent this number as a two odd primes. Okay, so we have for 45 we have 41 plus 3. Okay, there can be others also numbers that we can find out. For example, we take if you take 39. Okay, we take 39 also, 39 plus 5. Okay, so we can get many examples. Okay, and now we'll shift to b. B is 36. Okay, so for 36 we can have let's see, for 36 we can have what we can have. Nearest is 31. Okay, so 31 and 5. Okay, 31 plus 5. And second can be 29 plus 7. Okay, so anything you can write, it is up to you. Next is 24. Okay, sorry, it is c part, it is 24. Okay, so 24 can be represented as 19 plus 5. Okay, and you can take 17 plus 7 also. Okay, so this way we can represent. Okay, coming to d part is 18. Okay, so 18 is nearest is 17, but 17 cannot be taken as because you need to add 1, and 1 is not a prime number, so leave it. You go to 13, and 13. Okay, 13 will fit. 13 plus 5. Okay, 11 plus 5, 7 also can fit. Okay, so this is question number 6. Okay, now question number 7. Fine. Question number 7 is give 3 pairs of prime numbers whose difference is 0 2. Okay, 3 pairs. 3 pairs of prime numbers. Okay, whose difference is equal to 2. Okay, so we can have many numbers such, but we'll take 3 only. For example, you take 5 and 3. Okay, take 7 and 5. Okay, and we can take 17 and 19. Okay, and other numbers can be, take 41 and 43. Okay, so there can be many numbers, many pairs. Okay, we have written 4 pairs, you can write it yourself. Okay, now come to question number 8. Question number 8. Okay, so question number, which of the following numbers are prime numbers? So they are asking which number is prime number. So we have A part is 23, B is 51, and C is 37, and D is 26. Okay, 26. Which one is the prime number? We have A as 23, it is a prime number, and we have C as 37, that is a prime number. Okay, so you need to write 2 only, because these are the prime numbers. Okay, this is the question number 8. Now we have come to question number 9. Okay, what is question number 9? Write 7 consecutive composite numbers less than 100 so that there is no prime numbers in between. Means you need to write composite numbers that are in continuously, means one means you, as you count the numbers, you are going up, and those numbers are 7 numbers are there continuously, less than 100. Okay, less than 100, less than 100. Okay, and there is no prime number. Okay, no prime number is coming in between. Okay, so you need to find out this. Okay, so this, there is only one such 7 consecutive numbers where there is no prime number. And okay, consecutive composite numbers, sorry, consecutive composite numbers where there is no prime number is coming. So if you count after 89, okay, 89 is a, what is this, prime number. Okay, then you start 90, 91, 92, 93. Okay, then 94. Okay, then 95, and then 96, 96, and now it comes 97. Okay, so 97 is a prime number. So these are the only 7 consecutive numbers, okay, where there is no prime number in between. Okay, so this is the answer of question number 9. Okay, these are the, okay. Now we have come to question number 10. Okay, let's go to question number 10. Question number 10. Okay, what is question number 10? Express each of the following numbers as sum of 3 odd primes. Okay, sum of 3 odd primes as a sum they want to display. Okay, so question number 1, first of all, is 21. Okay, so they are saying that you need to represent as sum of 3 odd primes. Okay, 3 odd primes. Okay, you cannot take 2. Okay, they are talking about the prime, and those are odd also. Okay, so 21 can be represented as, let's try with if it is 13, 5, okay, it's there. So 13 plus 5 plus 3. Okay, this can be represented like this, and this will be equal to 21. So answer of this first question is this one. And the B part is 31. Okay, so for 31 we need to take we have to try. Suppose we take suppose we take 17 and 7, it will become 24, and then remaining will be 7, so it cannot fit, so we cannot take uh, 17 and 5. If we take 17 and 5, then it's 22, and remaining is 9, so it will not fit. So we'll not take 17 itself, we'll take some other number. So let's take 13. Let's take 13 and 11. It will be 20. Okay, it's good. So you take 13 plus 11. It will be okay. Now 7. Okay. Perfect. Perfect. Fine. So it will be 31. Okay. This is the answer. Now let's take part C. C is 53. Okay. So for 53 we can have some numbers like let's take uh, let's take 37. We can start with 37. Then let's take 11. Then how much will it be? It will be 48 and then 5. Okay. So this, there can be many other combinations also. You can try yourself. This is 53. Okay. Now part is D. Okay. D is 61. So for 61, okay, let's do some calculation here. If you 61 minus 53, it will be 8. So you cannot take that one. Okay. So you need to find some other solution for this. Let's start with 47. 47 and then take 11. How much it will be? It will be 58, 58 and 3. Okay. Now it's okay. So this is the one pair that we have found. You can find another also. Means this is not the unique solution. So you can find others also. So now we have come to question number 11. Question number 11. So question number 11 is write 5 pairs of prime numbers less than 20 whose sum is divisible by 5. Okay. We need to find 5 pairs. 5 pairs. 5 pairs. Pairs means 2 numbers. Okay. Less than 20. Those will be less than 20. Okay. And sum is divisible by divisible divisible by divisible by 5. It means some unit digit of any sum will be having 5 or 0. Okay. Only then it can be divided by divisible by 5. Okay. So you need to refer to the table. I am referring to the table. You need to also refer to the table. So take 7 and 3. 7 plus 3, it will be 10. So it is divisible by 5. So first one we found this. Okay. 5 pairs you need. And take 13 and 7. Second one, 13 plus 7, this will be 20. This is also divisible by 5, divisible by 5. Okay. Now we can take another number 17 and 13. Okay. Yes. 17 plus 13, it is 30. This is also can be divided by 5. Okay. Let's take 17 and 3 also. Okay. 17 plus 3. Okay. This is divided by, this is 20 and this can be divided by 5. And now take some other numbers. One more example we need. Okay. So 13 and 11 cannot be taken. With 11, 9 cannot be taken. Okay, 19 we cannot take because it requires 1. So we need 13, 13, 7 we have already taken. Okay, and 11, 7, no, it's not divisible by 5. And 7 5 not. Okay, so it is saying 5 pairs of prime number, it is saying. Okay, prime numbers, it is not saying odd prime number. So 2 can also be taken if it is required. Okay, okay, so 3 plus 2 you can take. Okay, 3 plus 2. Okay, this is 5 and it is divided by, can be divided by 5. Okay, so this is the answer of question number 11. Okay, now we have arrived to question number 12. This is the last question. Okay, question number 12, this is fill in the blanks. So fill in the blanks is there. So A is, it is a number which has only two factors is called, what is called, it is called prime. Okay, if any number having two factors, this is called prime. So in the blank you need to write prime. Okay, and now B is a number which has more than two factors, it is called composite. Okay, so composite, you need to write composite in the means blank. One is neither prime nor a composite. Okay, so you need to write in the fill in the blanks, you need to write first prime and then composite. Okay, both means blanks are there for both one, so you can write the both one, prime and composite. You can write composite also first and later on prime, there is no restriction. So and D part is the smallest prime number. Okay, you already know the smallest prime number is 2, so you write 2. E is the smallest composite number. Okay, you know, 1 is not a prime number, so 2 is a prime, 3 is also prime, the next 4 is the composite number. First composite number means the lowest one, the smallest one. Okay, and the smallest even number, what is small, and the next is the F is the smallest even number is 2. Okay, so this is the answer of question number 12. So this completes the complete exercise of exercise 3.2, and in the next session we will have the theory part of the divisibility of numbers, and then we'll take exercise number 3.3, I think, yes, 3.3. Okay, so we'll go by this. So this is all for this exercise. I think you got to understand how to solve the question, and doubts might have been cleared also. So this is all, we'll meet again. Thank you.